Hey there, name's Alex, and I'm no economist, but I am actually a mechanical engineer. Not a structural or a civil engineer, but we still learn a lot about a lot of the same stuff. I've studied it, I got my master's degree, and I've been doing it professionally. I've been working in the field for the past something like 14 years. I may not be the most brilliant one, but I could say that I'm relatively good at it, and it pisses me off to no end when I see people posting stuff like this, like they've uncovered the hidden secrets of the universe, or some hidden truths that you're not supposed to see. That's primarily people like 9/11 conspiracy theory truthers that will point out to beams on the wreckage site, on the disaster site, that look something like this after the rubble has been cleared, and they point to this beam almost as if being cut along a 45 degrees angle. And this is something that can only be posted by someone who really has no idea about engineering, about how materials work, how steel works, or how anything works, and how materials resist or counter loads that try to destroy them. Now, let's make a note that steel, structural steel, the type that's most commonly used in building materials, is a ductile material. That means it can take a lot of load and a lot of stress before it breaks or is torn apart. And it deforms a lot before it does that, as opposed to brittle materials that deform very little before they catastrophically fail by breaking or tearing apart. So a key note to make here is that structural steel is ductile, and it behaves like a ductile material, and it deforms a lot. It can extend or compress a lot before it fails and breaks. So let's look at what happens when you actually subject a beam. Let's say that the beam is positioned vertically in space, and it has to carry a load that's also oriented vertically, and we assume that it's oriented along its axis, and also let's say it's suspended or grounded in the ground securely, and that also creates a corresponding support reaction, we call it. And all of this results in normal stresses in a cross section of the beam that's perpendicular to its axis. But now, geometry permits us to do a cross section of a beam at any angle. It doesn't have to be perpendicular to the axis, it can be at any angle, and a weird angle is exactly 45 degrees. And what happens there is that in a plane that's not perpendicular to the axis of the beam, but exactly at 45 degrees relative to the axis of the beam, what happens there is that the load and the stress that results from the load is decomposed into two perpendicular components, two perpendicular stress components, vectors, that one of them is perpendicular to this 45 degree angle plane, and the other one is parallel to this plane. And what we call this is a shear stress, and their value is the largest in exactly the planes and the cross sections that are at exactly 45 degrees relative to the axis of the beam. And so what happens is that when you load this beam with a load that exceeds its load-bearing capacity, for ductile materials, what you would expect is exactly that it will fail as a result of the shear stresses that are exactly parallel or along this 45 degree angle plane. So that's exactly what I would expect to see if a structural beam is loaded beyond its load-bearing capacity, which can happen if other structural beams have already failed and given out, and very few other remaining beams are left to carry the exact same load that a larger number of beams were supposed to carry. And this is exactly what you would expect to happen when a beam is subject to compressive load along its axis, that it will fail as a result of the shear stresses along a plane that's at a 45-degree angle relative to its axis. So jet fuel doesn't really need to melt steel beams. It just has to make a few of them fail, resulting in that the remaining beams now have to carry more load that they were designed to carry or intended to carry. And also, it's not even that. It's also that you don't have to melt the steel beam, but increase the temperature just a little bit. This is the relationship between the stress and the strain that you can observe in a steel beam, and as it increases, there's a proportional connection between the stress and strain of a steel component, at least in the elastic zone. And when you load steel beyond the elastic zone, all deformations following that are plastic and permanent, and they don't recover once you take off the load. And when you increase the load sufficiently, the beam will fail. The beam will break, or it will shear, like we saw here, because of these shear stresses. But this is the stress-strain curve at room temperature. But what happens when we increase the temperature to 100 degrees, to 200 degrees? A few hundred degrees increase in the surrounding temperature makes the steel a lot softer and easier to deform and capable of carrying much less load. So jet fuel really doesn't need to melt steel beams. It only needs to soften them up so that they can carry less load. A few beams fail, and then the rest of the beams are left to carry all of the remaining load. And typically they have to carry more load than they were designed to, and they break and they shear at angles close to or exactly 45 degrees. So that's what you would expect from ductile failure under excessive load of a steel load-bearing beam. Anyway, that's all I had for this video. I've been Alex. I've not been an economist, nor have I been a 9/11 truther or conspiracy theorist. I'm just a mechanical engineer, and also I'm not a structural engineer, but still we learn and cover a lot of the same stuff in the mechanics and material science and material resistance courses that the structural engineers cover, and physics and material science applies all around and all across the board. So if you like this video, give it a thumbs up, drop me a comment below telling me you know exactly how the 9/11 terror attacks were staged and that they were an inside job. Subscribe to this video for future conspiracy theory debunking nonsense. There will be more. And if you're feeling particularly generous and you want to fund, no, I'm not gonna do any terrorist acts, but if you still want to fund me, or I'm not also gonna do any inside jobs and hoaxes, but if you do want to fund my future endeavors, whatever they may be, there will be links in the description of the video. And that's all I had. Till next time. Bye.